Okay, rectangular components are the real way. So why do I say the real way? So the book, you're going to go through, and some of the first homework assignments, you're going to need to go through and break up the forces using the law of sines, law of cosines, and whatnot. But the way that you'll end up doing it, more than likely, this is the only way I've ever seen it done in industry, is that you break up forces into x, y, and eventually the z components of the force. Now, often left, right, and up, down, would make the most sense, right? We usually define x as horizontal and y as vertical. But there's plenty of times when it's not as obvious, right? Say you're in outer space. What is horizontal? What is vertical? Who knows, right? So, but you still pick an axis and perpendicular axes of x and y. Now, so say you have this vector f. This vector f is the x component of it in the I direction, and the y component of it in the j direction, where I and j are unit vectors in the direction of x and y respectively. We talked about unit vectors. You guys are already familiar with probably 3 unit vectors that we use all the time, I, j, and k. And they are, what is a unit vector? It has a direction and a magnitude of 1. That's what I is. It has a direction in the x direction and a magnitude of 1, and so on. So what we're saying is that you can express this f vector as the x component of it in the x direction and the y component of it in the y direction. And then you can start to define what these are. So f in the x direction is equal to f cosine theta. F in the y direction is equal to f sine theta. I'll show you an example of this. So consider you have some axis. You have the x, y axis. Well, and then in that, you have some force F at some angle theta. Okay, so that force F has a component along the x direction, we'll call that Fx, and it has a component along the y direction, we'll call it Fy. Well, if you look at what that is, what do you have? You have cosine. Cosine of theta is adjacent over hypotenuse, right? So that's Fx over F. So you can solve that for f of x. So Fx is equal to F cosine of theta, right? And same deal with sine of theta. Sine theta is Fy over F. It's opposite over hypotenuse. So Fy is equal to F sine theta. And then lastly, you can figure out the tangent of theta is opposite over adjacent. So that's Fy over Fx. And so when we talk about Fx being F cosine theta and Fy being F sine theta, and then as I said, tangent of theta can also be found. That's where that comes from, through the trig. Okay, why would you do it this way? Well, because quite frankly, it's the way it's done. Because after you do this, you can just add up all the x components and all the y components, and then later as we add the z components, all those, and you're good to go. So let's consider a vector r. This r, you have multiple forces, F1, F2, F3, and so on. Well, there's a resultant vector. We talked about that you can have one resultant vector that is the equivalent of all these other vectors. Well, if F1 plus F2 plus F3 and so on, right? The r is the addition of, or the sum of all these vectors. Well, and we can also write r as the x component of it times I plus the y component times j plus the z component times k. Well, how do we figure out what the x, y, and z components are? It's really easy. This is why we break it into x, y, z components. The x component is just you add up all the x portions of the f. So the f of x1, f of x2, and so on. The y components, you add up all the y, and the z components, you add up all the z, and then you're good to go. So just through one, once you break up all these different things, and this is how it's done in industry, you'll break up, say you have 10, 15, 20 different forces, you figure out all the x forces, all the y forces, and all the z forces, you add them all up, and that's your new x, y, and z force. And again, as a editorial note, this is how I've done it in industry. This is the only way I've seen it done in industry. I've never seen it done with the law of sines and cosines. Okay, let's do example 2.3 from the book.